Alright, so this is the ventilator, very similar to the one we use at Union Hospital. This is a Drager Evita XL. Drager across the top, Evita XL right here. Very popular ventilator, not only nationally but throughout the world. Manufactured in Germany, so that's the background of this. I'm going to get into a little bit the startup for this. So if you'd like to start this thing up, it has a section of hard keys over here. And then this is a touch screen, and these are what they call our touch keys right here. So got keys on this side and then stuff right in here. Now, we can touch this screen all over the place, and I'll show you there's no real, well, thank goodness there's not a patient on there. But you can touch and change all kinds of funky stuff. But I'll show you one thing you have to do to activate that each time. So let's start off. I'm just going to shut the thing down. This is the start standby key right here. And this screen comes up, ventilation, we're active right now. We want to go to standby. We'll touch this and it goes yellow. When anything is yellow, it means it's asking you, are you sure you want to do this? And to confirm that, you just push this button in. Right now it's in standby mode, which means it's not ventilating at all. Across the top here, this is a red alarm saying standby activated. If you get tired of listening to the sound of it, you can hit this touch alarm reset. It should turn yellow, and then you activate it by pushing the button. And right now we're in our start standby screen. So you first turn the machine on. This is what you're going to see. The machine turns on in the back with a switch in the back, and we'll go over that probably at the end. So machine on. You can also hear the air compressor pumping. You got to turn the air compressor on. That's something else I'll put in the instructor video. And it gives you an option for new patient or current patient. Well, the nice thing with this is what we're going to do is we're going to use the current patient and use the settings that are in it already. So you're going to see this come up. It's a lot like Windows. If you want to get rid of something, you just touch the X and it shrinks it down. And now you say, well, how the heck do I turn this thing on? You have to go back to the start standby. See the start button. I'll touch start. It's yellow. To activate it, push the button in, and there we go. So, starting out, I'm just going to change the setting real quick to make this just a little bit easier. Okay. So starting on this machine, you have a couple different things going on here. Across the bottom, you see these are your settings. So this is what you have set to give to the patient. Everybody's pretty familiar with FiO2, or the oxygen we're delivering. Room air is 21%. Machine is, and how it runs in the lab is to keep it on 21%. If you increase the oxygen, you'll start pulling oxygen from that tank in the back. Once that runs dry, then this thing will constantly alarm. So leave it on 21%, even though clinically you're going to be up to some other amount of oxygen. So oxygen setting, VT is the tidal volume. That is measured as 0.600, measured in liters. That, of course, that's 0.6 liters, which is 600 milliliters. A pretty common tidal volume. Normal tidal volumes for people are going to be 10 milliliters per kilogram of ideal body weight is ideal for that. T-insp is our inspiratory time. So this is how long it takes the breath to get in each time. This is something that's usually only manipulated by respiratory therapists. It just tells you how fast the breath is going to go in. Some patients kind of crave, or you may have heard of being flow hungry, where they want more flow or the faster breath. That's when we can adjust that. In the lab, leave it at 0.9 seconds up to 1 second, and it will keep it pretty steady. Now with Drager, and this being a German machine, respiratory rate's not RR, it's F for frequency. So you can see our frequency set right here is 17. That's 17 breaths per minute. So it's kind of an odd setting, but we usually clinically try to keep them on even numbers, but we're going with 17 here. So 17 can easily be adjusted. And then PEEP, you see our PEEP, that's the acronym for positive in expiratory pressure. The standard setting is 5 centimeters of water pressure, and we'll leave it at that. That's how much actual pressure you leave in the lungs. PEEP is something that we use to help with oxygenation. Across the top here, you see we have a blue screen. There's no alarms going on right now. We get over this part right here, it says CMV, Control Mode Ventilation with Auto Flow. Well, on this machine, Control Mode Ventilation is the same thing as Assist Control. Assist Control is, if you remember a little bit about what different modes are, Assist Control is what I would term as the resting mode, or it is, we're going to be giving every breath, and if the patient starts their own breath, we're going to finish it. We're not going to let them do any work at all. We're not blocking them from breathing. So even though I have a frequency set of 17, in this case, if they want to breathe 20, they can breathe 20, but every time they take a breath, they will get 600 milliliters. Every breath is finished. So that's control mode. That's kind of the one I wanted to start with. Now, we have some waveform graphics across here. These go for each breath. You see on this one, this is pressure versus time. So we have pressure going up with each breath, going down. If you see this line that's running on right here, this baseline, that's actually should be about 5 of pressure, which is your PEEP. So that's what you're going to see with each breath. Now that correlates to the flow. Going above the x-axis is an inspiratory flow, and then expiratory flow is below the x-axis, going back this way. So you see you have inspiration, exhalation. Inspiration, exhalation. Now, there's a lot of cool stuff that you can get from clinically from those, but we definitely won't go into that today. That's about a 4-hour class. So, some different loops down here. This is called a flow pressure flow volume, or flow pressure volume loop. You see it's just monitoring that. You see your inspiratory side goes this way, expiratory side comes back. This is a flow volume loop, and it's doing the same thing this way. So it's looking at how those flows go in the lungs and come out of them. It looks at a lot of different things like secretions, bronchospasm, things like that. But as far as you're concerned, if all these things are lining up appropriately, and they will for each breath, that's what you want to see. Now, this flow over time, this will come into account when we start looking at when they start breathing on their own in a different mode like SIMV or CPAP. So let's look over here. P-peak, that is our peak pressure. That is the maximum amount of pressure we have in the airways. Our peak should be at the top right here. Peak pressures are increased by a lot of different things. Them biting the tube would be one, or anything that's going to decrease their dynamic compliance. So we see bronchospasm, the tube is kinked. A lot of different things can affect that peak pressure. That's actually the most damaging of all the pressures because it is the highest amount. So we want to try to clinically keep peak pressures down. You can do that by taking care of bronchospasm, suctioning appropriately, and whatnot. So peak pressure, that's the total amount of pressure in the airways. Mean average pressure in the airways over one breath. So mean is 11. That's just going to be calculating how high you're going, how long you're staying up there with what your PEEP's at. So average pressure in airways. P-mean is something you kind of get into when you get into neonatal ventilation. Like I said, we won't talk about any more about P-mean today, but it's just average. It really is a great number for oxygenation. I'll leave it at that. So MV, minute ventilation. This is measured in liters per minute, so 10.7 liters per minute. All this number is doing is taking your respiratory rate times your tidal volume, and it gives you liters per minute. So we know that the two things that affect ventilation, or when you think of ventilation, you always think of carbon dioxide. Think of getting rid of carbon dioxide on your blood gas and your arterial blood. The two things that affect that are tidal volume and frequency. So those two numbers go in, they multiply together to get that, and that number is really good to look at how well you're ventilating. PEEP, although we have a setting of 5, we like to see what the measurement is. So our measurement is 5 also. You can see small variations in that, but you shouldn't see more than 2 plus or minus of what you have set. Now this is kind of an interesting part. We have a VT, which is our tidal volume, and this is our VTE. So this is our exhaled tidal volume. So the machine, what it does, we have a set of 600. So, and remember, this is everything you're getting from the patient. So this is all stuff changing each time, everything on this side. So we're going to deliver 600, and we're exhaling 629 in that case. And 601, then we'll see what we exhale next time. Those shouldn't have a huge gap between them. If there's a big gap, there's an air leak somewhere. Also, the most important number of both of these numbers is going to be your XL tidal volume, because why are you given a tidal volume? Because you're trying to get CO2 out. I don't care how much air I put in, I've got to get it out. So the real important one is here. So to get CO2 out of your lungs, you have to look at that XL tidal volume. So that was real key. You'll have a little bit of variance in here. We have a test lung, we have an HME in line here. So you may have a little bit of change, but that's not a big deal. Frequency total, F total, 17. Well, yeah, because we have a test lung on, we have 17 set, we're not doing anything extra. F spontaneous, so this is when they go into a different mode. You can actually look and see how many breaths they're doing on their own. Now, if you watch with this mode, if I trigger a breath, here. Let me actually turn the trigger on, so maybe it will trigger a breath. Oh, that'd be the reason. Let's turn the flow trigger on. So now it'll trigger its own breath, so I didn't have the trigger on. So, going along, breathing 17, triggered a breath. Notice what happens each time I trigger a breath, the machine finishes it. It senses the lung starting to take a breath, or the patient, and it finishes it. Now in assist control, every breath is finished. So if they want to breathe 24 times a minute, they can. So if you look over here now, you see our F total is 26. The set 17. So they're taking, what, 9 extra breaths a minute? Our frequency spontaneous is 0. So you say, why is that? Well, in assist control, when they take their own breath and it finishes it, the ventilator does not count as a spontaneous breath. Spontaneous breath is when they start it and they finish it on their own. The machine doesn't finish it for them. So we have respiratory rate now is back down to normal, but while I was giving those extra breaths, we triggered a minute ventilation high alarm. It's because we're giving very large breaths each time, and we triggered our high alarm for that. But you see that the machines actually, or the patients actually kind of fix themselves in this situation. So this kind of fades back into the background, and it's not alarming. So let's say you're outside the room, you heard an alarm go off, you come in, and let's say it was like you just touched the top limit for a second, and you come in, then you can see what actually alarmed up here. Now currently there's nothing alarming because it's not red, but if you watch, I'll give those breaths again. As this minute ventilation increases, and what I have is set at 15.3, you can see it right there. As I start giving a bunch of breaths, this would not be good for your patient because they're going to be hyperventilating, blowing their CO2 down. They're probably super stressed out, biting on their endotracheal tube. But you'll see what happens as soon as I hit 15.3. It's a red alarm. You can hear it alarming. It's still above that amount. Come in and assess your patient. First thing you do is walk in the room, and I'm kind of like taking a quick glance over here, and then immediately go into the patient. Does the patient look like they're having problems? As this drops down below 15.3, you're going to see it go back to blue. So let's say you come in the room now and you see, okay, it looks like they got a little fast on their breathing, so their minute ventilation was up. I want to get this thing off of here, so I just touch this alarm reset and hit the button, and it gets it off of there. So that just shows you one of the red alarms that you may see with this. Frequency's coming back down to 17 now. Now the R and the C, so the R is resistance and the C is compliance. So resistance is resistance to flow. Resistance is easy to fix. It's usually bronchospasm, mucus, biting endotracheal tube, kinked endotracheal tube, those type of things are fast, easy to fix. Compliance is something that's much more difficult because that is the stiffness of the lungs. So these are constantly reading those compliance and resistance out. If you're interested in the calculation for those, you do take into account your pressures and your volumes. I'm sure you can find those online. Not going to go into those today. Your FiO2, you see that we have set 21 and our delivered's 20. Yeah, we're usually plus or minus 2, whatever. So the actual room air is 20.9. So would you think we're delivering less than room air? No, because where are we pulling that from? So 2021, that's all perfectly normal. In Tidal ETCO2, and unfortunately we can't simulate that unless we have a real patient on here, but that would show up right there, and it's measured from this, what we call a cuvette, and it measures across the stream of the ventilator stream. So as the air goes by, it takes a look at it and it says, okay, your CO2 is so much. So we don't have one of those in line because this test lung does not exhale CO2. All right, so let's get on to a couple of these keys over here. You really can't mess anything up by touching these keys. And I'll show you why. You got a main menu screen here. That's what they're on right now. The 1, 2, 3, these are different screens you can look at. Feel free. They're kind of generically set up. You got some different numbers over here to look at now. Some of them are larger. Not a whole lot of cool stuff with that. So generally leave it on 1. This is kind of what you're going to see at the hospital. Data. So this is a little bit more involved. You can see your data comes up on here, all of it. You have a logbook. Logbook's real nice because you can see exactly what's went on. You see I hit, my standby was finished at that time, and I need to change the time for daylight savings on this, but you see I changed my FiO2 from 50 to 21 initially. I also can go in here and look at trends. Okay, where has my minute ventilation been? I got a pretty nice waveform there, but it looks like it dropped right there really quick. Something must have popped off. You can see these peaks in here, and you can adjust this thing to kind of tell you what the measurements were at that time. See, we peaked in that minute ventilation. That was because we were hyperventilating that test lung. Frequency peaked. XL tidal volume dropped off a little bit. So, X that thing back out. Special procedures. These are different things that we can do. Inspiratory holds, expiratory holds. We get different numbers for those. The big key one is the inspiratory hold. If I hit this and hold it, it holds the breath in, you see? You see how this kind of different because it goes up, then comes back down and flattens off? That's your plateau pressure. So I'm not going to go into plateau pressure today, but it's real key when you're looking at ARDS and stiffness of lungs. So that's an inspiratory hold, and it holds the breath in. This shows you how much pressure it takes just to hold the lungs open in a static state. So that's a pretty cool thing. The expiratory hold is something cool too. So what it does, it actually holds their breath exhaled. You can see it's holding their breath. Patients usually don't like this when you do it very long, but it's going to measure how much extra PEEP you might have involved in there, like if you're air trapping or something like that. Nebulizer. I can turn that on. I touched it, hit the button here. It turns it on. You can hear it nebulizing. It's actually coming out of a small port at the bottom here. So you can give the nebulizer. You can hear it. It's only nebulizing with the breath, inspiration only. So your nebulizer treatments that usually last 8 minutes on a regular patient is going to last more like 3-4 times that. Shut that thing off. It's just a toggle. And then O2 suction button, which is nice. We touch it, and it's yellow, so we activate it. It silences the alarms, gives them 100% oxygen for a specific amount of time, and so we can suction because we know we want to pre-oxygenate before we suction. I'm going to shut that off so we don't burn up our oxygen tank back there in the back. Next that thing out. Logbook. A lot of different things on the logbook. We've kind of seen this screen already, but you can see all these different things turned on. You can see I turned standby finished, blah, blah, blah. It goes through. Suction interrupted. We had 2 high minute ventilation alarms. A nebulizer turned on. Gives you times on those things. CO2 sensor, nothing to worry about. That's the XL CO2. O2 sensor, nothing to worry about either. If it needs calibrated, you can calibrate it. It's very easy. The NIF is a negative inspiratory force. So this is a measurement we're going to look at when we're extubating somebody. We want it less than negative 20. So that means a negative 25 would be good. A negative 15 is not good. So we're just measuring how strong the diaphragm is. We touch this. We do a hold like this, and hold is expiratory hold. And I don't know if I can cause my lung to do a NIF. Pull it. And it pulled a NIF of negative 5, which clinically stinks, which means they're not doing very well. You want it negative 20 or less. So you can simulate that to see what NIF. Now, kind of a cool thing about a NIF is that negative inspiratory force. Most of us are 40 or less, but for a newborn baby when they're first born, they take their first breath, they have to pull a NIF of negative 90. So it's pretty drastic how much air they got to pull in initially to recruit all those alveoli that have been either collapsed or filled with fluids. So, but we're cool with a negative 20 or less on adults on the ventilator. PEEP I is an intrinsic PEEP study, so you look at if you have extra PEEP inside the lungs. It's very easy. You do this, hit start. It does an expiratory hold. It tells you if there's anything extra. You see it says PEEP I. 5.2, so our intrinsic peak's 5.2. We have 5.1 set, and we're trapping 4 milliliters. So, are we concerned about 4 milliliters? No. Would we be concerned if this said 100 milliliters? Yeah, that's a lot of extra air to keep inside the lungs. So, we X that thing back out. Our waveforms are frozen, and you see this little freeze thing, we just touch that and they start going again. It's no big deal. Inspiratory hold, that's just a quick button to give them a breath. You see I touch it. Every time I touch it, it gives them a breath. It's almost like bagging your patient on the ventilator. Now if I went like this and I held it, all right, I'm holding this breath, there wouldn't be a reason to ever do this. But if you leave your finger on it, it would do that, so hold the patient's breath. All that rapid breathing caused our minute ventilation to go up again. So there we go, we got a red alarm for minute ventilation. And then the nebulizer, we got a quick button down here. So let's get rid of this minute ventilation thing. We'll touch this, alarm reset, and then hit the button, gets rid of it. Great, so the next thing we're gonna get into are some of the keys over here on this side. And this is alarm silence, which is number one great key. I'll show you, first of all, I'll show you how to do the alarm silence. Let me just simulate the patient popping off the ventilator. So, test lungs right here. Low pressure, bad day, something's going on. Alarm silence, yeah, it would silence it for a second, but not for very long because you don't have a patient on there. Patient comes back on, everything's better, and this minute ventilation low, you hear it's not alarming right now because I have alarm silence on. If I do like this, it toggles and it comes back on until your minute ventilation comes up above your low end set, which is 8.2 right now. So, alarm silence is nice, although in your classroom here, I turn the volumes down, so it's not really that big of a deal. Alarm silence is nice. When you do hit it, it shows it on this side. It says alarm silence for 120 seconds. Now, if another alarm comes up, like let's say we have that low minute ventilation silenced and we have a pop off, it starts alarming again because that's a different alarm. So even though you're silencing one alarm doesn't mean you're silencing all of them, which is actually a safety feature. Let me get rid of that. Air supply down, it's looking at, it's pulling all that extra air and it can't keep, and the compressor on the bottom can't keep up to it. So let's let it catch back up to normal here. Give it some extra breath, inspiratory hold. Okay, alarm silence is still on. You can see over here 67, 66 seconds. Make sure that clinically before you leave the room that you hit this button right here and you take the alarm silence off because you want to know if your ventilator's alarming. Alarm limits. Just if you end up setting a really high tidal volume on this or something and it keeps alarming high minute ventilation, you hit the alarm limits, you go in here and you can increase this to where you want with the knob, decrease it, and then you hit the knob for enter and then it will go. Now if I go over to here, this frequency, I turn it up to 75 and then I hit X, or turn it up to 98, then I hit X and I go back into it. Notice it's back to 50. It's because they didn't activate it by hitting the button over here. Anything that's yellow, let's go up to 60 and I'll turn it on there. Next, sensor parameters, nothing to worry about there. And system setup. Actually, I'll go in here right now and let's see, country. What is it, 12:21 right now, ish? Yeah, so I'll change the time. It's European, so they got day, month, year, which is kind of funky. So 11/6. Anyway, there's no really other reason to use this. This is just kind of the background, and we could put it in, you know, all kinds of different measurements if you wanted. And then your last button is your start standby. If I just hit this, it's going to say, "Are you sure you want to do this?" Well, if I'm ready to shut it down, I do. So I hit standby, hit this, and it goes in standby again. And this is where we started at in the beginning. So, alarm reset. Let me start this back up again with SimV mode, and I'll talk about the other two modes of ventilation. So SimV is also known as assist control. So we're going through that. We've talked about that. Every breath They get a set number of breaths per minute, and then if they take their own breath or they trigger their own breath, the machine finishes each time. This is the resting mode. The next one's SimV, and I'll show you how to get to that. You can either go to your ventilator settings right here, or you can touch down here, and it pulls up this ventilator settings screen here. So let's go right here, and we'll touch this one. It's pulling it up. So I see the SimV mode I want. It's right here. So just click on that tab, and it brings up. You see the difference is there's CMV. When I hit SimV, watch these here. You'll see something extra come up right there. Pressure support. So you can only have pressure. You never have pressure support in assist control. You can have it in SimV and CPAP, but I'll show you what that really does. So let's just say that looks good. So let's say I want that mode. I want to do it. So I waited too long. Touch there. It's yellow. Activate. You'll know that the mode is activated when you look up here and it says SimV pressure support. So the difference with SimV is they're going to get a set number of breaths per minute, but when they take their own breath, they've got to do a little bit of work. So instead of getting the whole volume each time, the ventilator is not going to give them the volume when they start their own breath. It's just going to give them a little bit of help, and that help is the pressure support. So show you how this works a little bit. Let me turn this respiratory rate down, because in SimV you usually run lower rates because you want them to start breathing on their own. Let's see. There's a ventilator breath. There's a ventilator breath. All right. See that? There's a spontaneous breath in the middle there, and there's one there. You can see this by the gray. See how the gray on the flow waveform? It's a ventilator, spontaneous, a little flow disturbance in there. See the gray? Those are patient-triggered breaths. So the patient's taking a breath on their own. What you like to see is, when they take a breath on their own, that they're real nice big breaths like this, which means they've got real healthy breaths going in. They're doing a lot of good breathing. Now, the SimV, the nice thing with that is, if they stop breathing, it goes back and keeps giving breaths at whatever your set rate is. So a rate set at 12, they're never going to get less than 12 breaths a minute. So they were up to 18 breaths a minute there, and we had six or so spontaneous ones. And you see this starting to go down as I stopped breathing for it. So ideally what SimV is for, and you say, oh, low minute volume. Well, that's concerning because it means they're not getting enough tidal volume and they're not getting enough respiratory rate. So I'll change the alarms on that because it's kind of annoying. So what you traditionally do with SimV is I would turn this rate down. Let's go to 10 and then see if they breathe on their own. And you're going to hit a certain point, usually about 10 or 8, where they start breathing on their own. And what causes the majority of people to breathe is carbon dioxide. So when the carbon dioxide starts to build up, trigger their brain, send the impulse down to their diaphragm, so they contract, open up, let's breathe some more. And that's kind of what SimV is for. So even if they are sedated, as you start to bring them out, you turn their respiratory rate down, and it's going to trigger them to breathe on their own. And then you can monitor. Their breathing with that. Monitor the spontaneous breaths. So let's say they did good on a respiratory of 10, because let's say they were breathing actually 15. So we're cool with that. So let's say, okay, the patient's up, talking, looking pretty great. The old school way to wean is to take this and go down to 8. Okay, let's see how they do on 8. All right, they still breathing okay. They still breathing the appropriate amount. Their CO2 not building up. Yeah, that looks great. So we'll take it down lower. We'll take it down to 6. No problem with this is it kind of wears the patient out because you're really weaning them slow. So this is only going to give them 6 breaths a minute, which means if they stop breathing, they're going to only get a breath every 10 seconds, which is not at all adequate for anybody. So we'll keep an eye on them at this point. A lot of times this time, if they're down to a respiratory rate of 6 and they're breathing enough on their own, let's say it's 28, which is a little bit high, but let's say they're breathing enough on their own, we'll actually change them over to the last mode, which is, think of it as a spontaneous mode, or it's also called CPAP and pressure support. So it is right here. We touch this. Watch what happens with all of our different settings. They're gone, which means CPAP and pressure support, and I'll activate that. This has just, really just 3 settings: your pressure support, your PEEP, and your FiO2. In other words, they have to breathe on their own. If they do not breathe on their own, it's going to go into apnea ventilation. Every breath they take, they're given a little bit of help, and that help is that tenor pressure support. That's just to overcome the resistance to tubing, the endotracheal tube, and whatnot. So we're supporting each breath. Let's say they're doing great. They're breathing a rate of 14, 600 tidal volumes. These nice tidal volumes they're getting with these. And let's say they go to sleep, or they have a little bit of sedative on board and they stop breathing. This is what happens in CPAP mode. So it's going to take a while, but what it's going to do is going to go into what they call apnea ventilation. It's going to alarm initially, and you've probably seen this on your patients in ICU. We're trying to wean them, and they're kind of like borderline. Apnea ventilation is not a bad thing. It's just kind of like our backup system. It says apnea. They haven't been breathing very well at all. And you see now it starts breathing. It says apnea ventilation, which means it puts them back over assist control. And this will constantly just kind of beep, 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 beep. Hey, by the way, you're walking by the room. Hey, they're not breathing on their own anymore. We're doing it for them. So if you were trying to wean, it's not working. So apnea ventilation is kind of cool because it does that for the patient. It will never let them go totally apneic. But you see every once in a while it's going to alarm like this. So the big key to this is you come in the room. How's the patient doing? Well, they're sleeping and really have no respiratory effort at all. Well, I'll probably call the physician and get them back on a different mode. Let's say they're awake and looking at me and like, get this tube out of my mouth. I'll probably go up here, hit alarm reset it, and then you see what happens. It actually goes straight back to CPAP and pressure support and lets them start breathing back on their own again. So you can try that mode. There's some different modes on here, and I'll talk about them just shortly. PCD Plus is pressure control mode. What it does, we're giving pressures instead of tidal volumes, a little more technical. We have APRV, airway pressure release ventilation. We'll not see that very much. PCD Plus Assist is assist control and pressure control. And then MMV is it is mandatory minute ventilation. That's what it is. We don't use that very often either. But what you're doing, you set a minute ventilation, and it will help them to a certain point. If they're doing really well on their own, it'll let them go on their own. If they slow down, it'll help them out again. So it's kind of like a beefed up SIMV. But our 3 ones that you're going to see mainly, and let me get this guy back to assist control, so that right here, so we can breathe on our own a little bit more. So we're back to CMV, and increase my rate a little bit. Rate of 6 isn't sufficient. I like 14. So you have your modes across there, and you can change it into that if you'd like, but the probably the easiest one just to get everything down is just put them in assist control or the CMV mode with this. Some different things you might run into. If you have excessive alarms and it says leakage, there's a leakage in the system somewhere. It could be down here. It could be with one of these little pieces. That's pretty much what respiratory therapists do, is we troubleshoot alarms almost constantly. So you just look back, find where there's a leak in some area, and then we fix that. Now, if there's ever an alarm, clinically, if there's ever an alarm going off and you don't know, you walk and you say, I don't know what that means. You look, remember, you glance here, then glance straight at your patient. Your patient looks like they're doing bad. Immediately grab your bag, valve mask, ambu, whatever you want to call it, put it on an endotracheal tube, and manually ventilate them. Disconnect the ventilator, call RT to come fix the ventilator, but as long as you ventilate your patient. We came into the room too many times where people, this thing's alarming red, and everybody's going up here trying to touch things, and then what's going on here? And the patient's over here like dying, essentially, because somebody's worrying about this machine when all they need to go over there to do is put the ambu, the bag valve on the tube, and give them the breath. Of course, plug it in oxygen, give them the breath, and then to get them by with that. So that's really the key that will save you in all situations. The respiratory therapist would much rather show up to the room with the patient being bagged and the vent alarming than the vent alarming and everybody kind of saying, well, I think we need to change this or that. No, just bag the patient. That takes the ventilator totally out of it, and we mess with the ventilator later because the patient's number one in the situation. So.